Alright everybody, so I'm going to start taking off this wiring harness that's trashed, and while I'm doing this, let me tell you about a few of the things that I found out about this motor that I gleaned from numerous websites and forums online. There's plenty of information out there about this motor, the inline six-cylinder Mercury, which apparently was made with different variations for quite a long time. Apparently, in the mid '80s, they really started getting this motor right, and I guess those are the models that are considered the most, well, I guess reliable, because there's a big debate over whether or not this motor is a good motor or not. I just took off this wiring clamp. It's got this little well, no, it's a little metal clip here, and that goes right here on top of the ignition coil. It mounts to the actual ignition coil frame and holds the wiring harness right here. So I just want to make a note to myself about that. So anyways, so you get a lot of guys like asking questions like, oh, they found the cheap one and they're considering buying it, should they buy it? And you'll get several guys will chime in and say, oh no, you don't want that thing. And some of them will even admit that, this motor is a lot quicker than, that the power to weight ratio in this motor is really great. So this motor is a fast motor, but that reliability wise, you want, an Evinrude or this or that or whatever. But then there will be other guys that will come on and say, look, it's like any other motor. If you maintain it correctly and make sure it's getting proper cooling and proper fuel, that it can be a reliable motor. So there's a difference of opinion there. And I think one guy's post kind of summed it up best. He said it's the classic Ford versus Chevy debate. You're just going to have guys that love the motor and love their motor more and are going to knock it, and vice versa. So you can't really go by that. People said that, that the wiring harnesses on all the early models are going to be trashed like this. I don't know if you can really necessarily single out the Mercs to that, because my Johnson that I worked on, two of my Johnsons had the same kind of cancer with the wiring harness. So that's not really a indicator. They did talk about that this motor could have a catastrophic failure if it was not cooled properly, and that typically your top cylinder, number one up here, so top cylinder is number one, bottom's number 6. The number one cylinder can grenade and blow a hole right through the piston, and even in some cases, I guess, have made holes through the case. And I guess the reason why number one fails is that number one is going to be the first one to overheat if you have a problem with the cooling system. So it's very important to make sure that the water pump is working correctly in this unit. And there is a telltale or pee-hole or whatever you want to call it over here, which is what you're basically supposed to be making sure that water's squirting out of there. If you don't have water squirting out of there, you've got a problem with the water pump. And my understanding is that these don't have a thermostat in them, so you don't have a typical temperature gauge set up on these. So you can actually put somebody had mentioned you can actually put a water pressure gauge on here somewhere, so you could actually monitor the water pressure. So if you're up in the front driving the boat, you can't be looking back there to see if the telltale's squirting water out the whole time, but you could have a water pressure gauge up front, and that it will give you very low reading when it's idling, but then at speed you can get like 10 psi apparently. So that's something to consider, I guess. So one of the things I'd have to look at on this thing is make sure there's no holes in any of the pistons and that. The wiring harness. Okay, so getting back to this wiring harness deal. Well, the wiring harness is available. Brand new aftermarket replacements are available for the complete engine wiring harness. I found one website. I'm not even going to say the name because I don't even want to plug these guys, because they have they're supposedly a site that specializes in Mercury parts for older Mercuries. they have the wiring harness and they want $183 for it. Well, I can tell you right now that if you shop around, you can find that wiring harness for as little as $120. And they're all aftermarket wiring harnesses. So anyways, needless to say, if you really want to buy a brand new wiring harness for one of these motors, I would recommend you make sure you do due diligence when it comes to shopping around, because there are some sites that appear to be reputable and have a good following that are selling these wiring harnesses for around $120, $140. In my particular case here, there's no way I'm going to get on the phone and call for a brand new wiring harness for this pig, because again, I don't know whether or not my electronic switch box, I don't know if I've got an ignition problem, I don't know if I've got a mechanical failure, and I know that I've got gear case issues. So let's get this wiring harness out and see where we stand. So the next thing I'm going to do is I'm going to undo this electrical tape that's on here so I can see these individual conductors and get a good feel for where they're going, because I am pretty sure that I'm going to find that, as I suspected, that the two wires here from the alternator junction actually go directly to these two yellow connectors on this rectifier. So to sum up, if you're going to buy yourself a new wiring harness for one of these, make sure you shop around, because there are some sites out there that appear to be just taking advantage of the fact that they have a good website name. Alright, so I've removed this tape, and as I suspected, the two yellow wires coming from the little connecting block here to go to the alternator, these two wires here go directly to the two yellow connections on the rectifier, which is what I had expected to find. So I don't even need to really make a diagram for that to know that I'm going to want the new wires to go to there if I end up creating new wires for this. So I mean, a couple of ring terminals and a little bit of wiring, and that part of the wiring harness can be subbed out pretty easily. Matter of fact, begs the question, if they had just undone this tape way back when they did this section and replaced it by splicing here, they could have just done a whole, could have not had the splices and run new wires right up to here. That's interesting. That screw does not have the kind of threads I would expect to see on it. I wonder if that's the wrong screw. Well, I guess they're not really using that connecting block. No, that is, okay, that connecting block's just plastic. It doesn't even have a metal. It's not like a typical terminal block. Why did I do that? I will take this off altogether so I can pull it up here and, oh, what the heck, let's do a continuity check measurement on this alternator, on the windings of the flywheel. Why don't we see if we have bad news right off the get-go? Let's see if there's enough. Of course not. That insulation is toast pretty far in. This is just bare wire to bare wire, so if it's touching in there, obviously I'm not going to be able to make a proper continuity check on this. Let me slice this outer sheathing back a little ways and see what I can find. Alright, no matter how far back I seem to cut in this sheathing, all I keep finding is more and more destruction and carnage here. So that's all just bare wire. So that's already bad news, because that wire just goes up and disappears inside here. And this wiring is part of the actual coil pack there that consists of the alternator. So I have no idea whether or not I can perform some sort of magic and attach new wires onto the inside of that winding. I do know this, I'm not going to even be able to attempt it until I take it out of there. And to take it out of there, I'm going to have to pull a flywheel. So we'll stop with that and go back to what we were originally messing with, which was the rest of the wiring harness. So, you know what I said about number 6 cylinder being the first one to grenade. That's, you know, this bolt being part way out makes me wonder if this cover was off. Yeesh. Wonder if somebody was already taking a peek in there and looking at something horrible. All right, well, we'll soldier on with the removal of the trashed wiring system. All right, so next I'm going to remove this 7/16 inch bolt, which connects this big heavy cable right here, which goes over to one of the bolts that holds on this access cover. So it's grounding this cowling, this lower engine case or whatever you want to call this, to the engine block, making it all common ground. And you've got this one, and then you've got underneath it, you've got this one, which actually comes in from the plug, from the receptacle here. So this is where the negative battery cable comes in and grounds to the motor, and then it's grounded to the actual engine block via this cable. So they're basically using, for a ground path, they're using the cases and the block itself. So that's obviously critical, and it's got the same problem. It's got the sheathing is wide open here and all deteriorated and failed, and I can see the copper conductors inside are all corroded. So no surprise, everything else was that way. Why wouldn't it be? This one's actually in very good shape. It makes me think this was replaced, that this is more modern. Well, anyways, so by getting those grounding cables out of the way, that exposes two little bolts right here that hold a clamp in place that actually keeps this plug captive down there. So if I take these out, I should be able to remove this whole plug and bring it out here and be able to get a better look at what we're dealing with here. I was just thinking to myself, please don't snap. It snapped right off. What a shock. And for those of you who think that I should have applied something to those threads, well, chances are no amount of spraying on the top here was going to get to those threads, which are underneath. Ow. Force of habit. This wire sprung and hit my finger, and it gave me a little jolt that is identical to the feeling you get when you get a little electrical jolt. And my conditioned response when I get that feeling is to yank my finger away, even though logically there's no way that there's going to be electricity present in this thing. It's a dead motor not hooked up to anything. Funny how the mind works. Well, now that one unscrewed. That's nice. 1 out of 2 ain't bad. That's going to be a real pleasure drilling and tapping for that. But hey, who knows? Maybe it won't even remotely be my problem if this ends up being a junked motor. I see that little washer fell down in there, and it is stainless, so I can't get it with a magnetic tip screwdriver. I want to get that little washer before it disappears. Alright, so this clamp, I was hoping, is supposed to come straight up once I took those bolts out. I'm worried that it might be that it's supposed to actually move back with the plug as the plug backs out, but it can't because that stud is left behind from the broken off bolt. So it's almost impossible to get anything to pry on this thing. So I'm just using this slide. Try and coax it up. Can't tell if that's moving or not. You know what I need to do? I need to get a block of wood under this thing so that it's not swinging on me. That's fairly stable. There we go. That's what that doohickey looks like. Once that's out, then this plug should be able to back out through the opening in the cowling there. Of course, this is probably a seal. Grommet, like tight fit. Yep. Pop that out. Up and out. All right. Boy, there's a lot of pieces of insulation and garbage down in there. I'll try and shop vac that out later, maybe. Actually, this whole thing might be able to drop down once I unbolt the front there. Okay, it looks like 7 wires, not counting the big ground wire and the big positive battery cable that goes directly to the solenoid, the starter solenoid. So this one only provides the 12 volts to the starter when the solenoid closes. So that's on the input side of the starter solenoid. But for small wires, we've got these 2 thick wires that pair up together. One of them goes right to the rectifier, so the 12 volts coming out of the rectifier is going out of this wire through the boat circuit and then probably coming back on this wire and going up to the red connection on the switch block. Pretty straightforward. So which of these pins is which? That might be an interesting thing to know. I mean, I could probably find the wiring diagram online easy enough, but I think I am going to try and use my continuity check on my meter to figure out exactly which pins are which. All right, so we got kind of a nightmare scenario here of all of this bare wire in close proximity to each other. So if I start doing continuity checks from pin here to wire here, just because I get continuity doesn't mean I'm on the right wire, because it seems like they're all going to be short. They all have the ability to just be touching each other. So I removed this tape, all of this tape that was on here, so I can get as close to the plug as possible. Alright, so I had peeled off the electrical tape from here and discovered that there is just a little bit of insulation left that's actually intact on the wiring right before it goes into the molded plug. I wonder if I'm going to be able to get to splice onto that and actually save this plug end. So what I'm going to do is I'm going to cut this wire right here. This wire, God, it's so rotten. This wire goes to the white connection on the switch box. And it appears to be a white wire that's just really dirty. So what pin does that correspond to? That's what I'm going to find out. Alright, so let me figure out the pinning of this plug. So I've got the plug, it's facing up, but it's oriented with these wires facing that way. So if it was in there right now, this would be the top. And the layout of the pins, you get these 2 big pins with 1 small pin to the right of it and 3 small pins to the left of it. That right there is split for some reason. Probably not supposed to be like that. I'm not going to worry about that right this minute. This should probably be like that. There we go. Okay. So anyways, so these 2 big pins clearly are the heaviest current carrying pins. So those have got to be, one of those has got to be the big 12 volt going to the starter. solenoid, and one's got to be the ground. So let's see which one's which. I've got my continuity tester on the meter on, and that's got a beeper, so I don't even have to look at it. Alright, I'm not getting anything there, so it must be the ground, which is this one. There you go. Okay, so the bottom pin is ground, so the top pin must be the starter. It is, okay. That rules those two out. So now, I want to know which one is this white wire that I just cut off, which goes up to the, well, until I cut it, it used to go up to the switch box. Okay. Alright. So this small pin that is closest to the left side of these two big pins, that's the white wire goes there. Okay. The next wire up on the switch box is the heavy red wire that goes to the red terminal in the switch box, so that's going to be this one right here. I wonder if they did something sneaky like actually have the once they did something sneaky like actually have that tied to the other pin. I bet you it is. Bet you this 12 volt wire is a separate wire that goes to the same. Alright, that's the ground, so this big pin on the top I just said was 12 volt. That's exactly right, because you got the ground, the positive, and then you got 1, 2, 3, 4, 5 more little ones, right? So they got the red wire from the switch box right there, and the red wire coming out of the rectifier right here. They both come in right here and are common to each other. Okay, so I can take that all mess off right now. To aid in making a good connection, these little nuts are brass. In addition to being a rectifier, this block is probably also a regulator. What the hell is that? Oh, it's just a big piece of insulation fell off. Alright, I already figured out which one this white wire is, so we can get rid of that. Alright, this next color up is almost like a beige color. Tan. The insulation is in such bad shape on these wires, it's almost impossible to tell what color these wires are. Alright, let's figure out which wire this one is. Which pin this one is, I should say. Yeah, I don't know what color that is. Brown, I guess. Okay, the brown wire is the lone small pin to the right of the two fat pins.